For as long as we've gazed at the night sky, we've dreamed of reaching the stars. This longing is ancient, woven into our stories, our art, and our deepest curiosities. We crossed continents, sailed oceans, and learned to fly, always pushing boundaries. But space was the ultimate challenge. The nearest star, Proxima Centauri, is over 4 light-years away. With old technology, that journey would take tens of thousands of years. Einstein's theories set a cosmic speed limit. Nothing with mass could reach, let alone exceed, the speed of light. For a century, this law defined the boundaries of our ambition. The stars remained beautiful but distant dreams. Yet humanity questions. We push against every wall. Scientists explored quantum mechanics and relativity, searching for loopholes. They theorized, experimented, and refused to accept the impossible. And then on August 5th, 2025, everything changed. A quiet discovery shattered the old limits. Suddenly, the universe was no longer out of reach. The dream of touching the stars became a real possibility. Our story of exploration had found its next chapter. The cosmos was calling, and this time we could answer. The age-old dream was about to become reality. The journey to the stars was about to begin. The world awoke to news that felt like science fiction. A team of physicists had achieved faster-than-light travel, not just a little faster, 10 times the speed of light. The breakthrough came from labs in Geneva, Chicago and Tokyo, led by Dr. Aris Thorne and Dr. Lena Petrova. They moved a microscopic particle across a vacuum chamber. Faster than light could travel the same distance. The implications were staggering. Every law about cosmic travel was rewritten overnight. The scientific community was skeptical, but the evidence was robust and repeatable. The math held up. The experiment worked. They hadn't broken physics. They'd found a loophole in space-time itself. This became known as the Thorne-Petrova effect. It was a paradigm shift, like Copernicus or Newton. Suddenly, interstellar travel was no longer a fantasy. It was an engineering challenge. The universe felt smaller, more accessible. Humanity stood at the dawn of a new age. The dream of reaching the stars was now a tangible goal. The world united in wonder and anticipation. The impossible had become possible. The Thorne-Petrova effect was the key to the galaxy. The age of interstellar humanity had begun. Our place in the cosmos was forever changed. The stars were no longer out of reach. The journey was truly underway. In 1994, the Alcubierre drive proposed moving space itself. Like pulling a rug beneath your feet, it needed exotic negative energy, something we couldn't create. For decades, it was science fiction. But the Thorne-Petrova team found a new way. Dr. Jian Chen theorized space is a sea of quantum foam, bubbling with virtual particles. Using powerful magnetic fields, they created tiny regions of negative energy, enough for a small warp bubble. The Alcubierre-Chen manifold was born, a bridge to the stars. The impossible journey is now within reach. Imagine space-time as a vast rubber sheet. Gravity creates dips in this sheet, pulling objects together. Traditionally, to cross the sheet, you travel across its surface, limited by the speed of light. The Alcubierre-Chen drive folds the sheet instead. It generates a precise energy field, pinching space-time in front and expanding it behind. The ship rides a wave of space-time, safe inside a calm bubble. Immense energy is required, but precision is the key. Magnetic fields must be tuned to exact frequencies, like making a crystal glass sing. The Thorne-Petrova team found the right frequency to resonate with space-time. The ship inside the bubble is still. It's the bubble that moves. This is the loophole. Nothing with mass travels faster than light, but space-time itself can. We see this in the universe's expansion. Distant galaxies recede faster than light because space itself stretches. The Alcubierre-Chen drive harnesses this principle locally. The ship never breaks the cosmic speed limit. Instead, it surfs the fabric of reality. The impossible becomes possible. The universe's own rules are the engine. The stars are no longer distant. The journey is real. The future is here. Humanity is ready to ride the wave. Until now, space travel relied on primitive methods, rockets powered by controlled explosions. Chemical rockets, like Saturn V, were powerful but inefficient for interstellar journeys. Even advanced ion drives and solar sails were far too slow for the stars. All these methods were bound by the rocket equation and the speed of light. Probes like Voyager took decades just to leave our solar system. They'd take 40,000 years to reach another star. The Alcubierre-Chen drive is a complete departure. It's like trading a horse-drawn cart for teleportation. At 10 times light speed, Proxima Centauri is less than 5 months away. The centre of the Milky Way, 25,000 light-years, could be reached in 2,500 years. Generational ships and advanced robotics make such journeys possible. The galaxy is no longer a distant dream. It's a landscape we can explore. The old barriers have fallen. The universe is open. Our first steps have become a giant leap. The age of true exploration has begun. The stars are within our grasp. The discovery is monumental, but scaling it up is a colossal challenge. We've moved a single particle. Now we must move ships. Energy demands are still immense. New power sources are needed. Fusion or even more exotic technologies may be required. Safety is critical. Compressed space-time could unleash dangerous radiation. We must learn to navigate, shield, and control the warp bubble. The universe is full of obstacles, dust, radiation, unknowns. We don't yet understand all the consequences of warping space-time. Global cooperation is essential. This is a project for all humanity. The greatest challenge may be uniting ourselves for the journey ahead. The cosmos awaits, but we must be ready. Despite the challenges, optimism prevails. We stand on the threshold of a new era, no longer confined to one planet. The door to the cosmos is open. We can now plan missions to exoplanets, search for life and study the universe up close. The ultimate laboratory is within reach. Humanity could become multiplanetary, even multistellar. This is our insurance policy against catastrophe, a chance to ensure our survival. The night sky is no longer a symbol of isolation, but a map of future destinations. The children of today may see worlds we've only imagined. The legacy we build now will echo for generations. The stars are waiting for us. We are at the dawn of a new chapter in the human story. The dream of the stars is now an engineering challenge. The work of Thorne, Petrova and Chen has given us hope. The coming decades will be filled with research, setbacks and breakthroughs, but the goal is in sight: humanity unbound from a single star. This journey belongs to all of us, a testament to our ingenuity and curiosity. The most imposing barriers can fall. The future is something we build together. We must keep asking, exploring and dreaming. The cosmos is waiting, and now we can answer its call. Our journey has just begun. Thank you for joining us on this exploration. The universe is full of wonders. Stay curious. Our greatest adventures are still ahead.